Okay, in this video we're going to be looking at the relationship between multiplication and division. So the relationship of multiplication and division. Yesterday we looked at relationship between addition and subtraction. You're probably going to see some similarities between what we did in the last video and what we do in this video. Okay, so let's start off by just doing some practice again with tape diagrams. So for letter A, I have the expression 8 divided by 2. And if I want to picture that as a tape diagram, or represent that as a tape diagram, I'm going to do that by starting off with 8. So I'm going to draw 8 units. 2, 3, 4, 5, 6, 7, 8. So there's my 8 units. And again, I know that this whole amount right there is 8. Okay? Now, because I'm dividing it by 2, I am going to break these 8 into groups of 2. So, here's a group of 2. 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 So one group of 2, one group of 2, one group of 2, one group of 2, which gives me a total of 4 groups of 2. Okay, for my multiplication problem in letter B, I have 3 times 2. So what I'm going to do is I'm going to start with my first group, which would be a group of 3. Okay, so this right here is my group of 3. But now I'm multiplying that 2, so I need to have this 2 times. So I have already one group, and now I need another group. So there's my next group of 3, which then, if I count up, I have 1, 2, 3, 4, 5, 6 total. So I know that my answer there is 6. Okay, so I'm going to have a problem here. I have 9 units. So I first want to start this example by showing what 9 units looks like. So I can see 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. Now, the next thing I want to do with these 9 units is I want to divide them into 3 equal groups. So I'm going to divide to 3 equal groups. Okay, and if I take these 9 and I divide them into 3 equal groups, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I want to represent that with an expression, I could say that I had 9 divided by 3. So there's my expression, 9 divided by 3. Okay, so the next thing I want to do is I want to take my tape diagram and I want to show what it would look like to multiply 3 by 3. So if I multiply 3 by 3, I'm going to start with my 3 squares. Okay, and then since I'm multiplying it by 3, I need to have that 3 times. So 1, 2, 3, there's 2 times. 1, 2, 3, there's 3 times. So now if I wanted to take our original expression that we had 9 divided by 3 and I want to alter our expression based on what we just did, I could take my 9 divided by 3 and then I can end up multiplying that by 3. And if I evaluate my expression now, if I take 9 divided by 3, I get 3, but then if I multiply it by 3, I end up getting it back to 9. So I end up getting back to where I started with. Which then takes us here. When a number is multiplied and divided by the same number, the result is the original number. So if you're taking something and multiplying and dividing it by the same thing, you're going to end up with what you started with. So an example of that, if I take 16. Okay? I end up dividing it by 2 and then multiplying by 2. What am I going to end up with? Well, if I multiply and divide, or divide and multiply in this case by the same thing, divide by 2, multiply by 2, those two end up really canceling out. And we end up getting exactly what we started with, which in this case is 16. So now thinking of it a different way, if I have 24 and I want to divide it by 4, and I'm going to multiply it by something, I don't know what, but I know it needs to equal 24, I can be thinking to myself, okay, if I'm starting and ending with the same exact thing, that means my division and my multiplication have to cancel out. Well, if I divided by 4 here, that means I have to multiply by the same thing, so I'd have to multiply by 4.